Hello everyone. Today we are going to do arrays. Arrays is a very fundamental data structure, but let me tell you, it is a building block for a lot of advanced level concepts. Whether it is dynamic programming, dealing with the strings, or other topics, it is a very fundamental topic. What we are going to do is learn it, cover its basics first. So you need to just remember two things. Number one, it is more like a collection of items. Collection of items. And what is number two? Number two is that it stores data in contiguous memory allocation. Spelling is wrong. Sorry. Contiguous memory. Now I will break both of these terms to you in very simple words. See, we know that there are a lot of data types. I mean, there are not a lot of data types, but yes, there are. We have some fundamental data types that are int, char, bool, float for holding the decimal point values. So we can make an array of any of this data type. what what's important to know, what's important here is that each array can only have a similar data type. Let me explain you this with the help of an example. If we have an array, this is how we this is like a pseudo code for an array. We'll be discussing how we represent that in a moment. Let's say this is an array, this is just a pseudo code, and we are having 1 2 3 over here. So this is a valid array. Because why? It is having all its value of integer data type. Let me give you another example of an array where I have one A and let's say false. Everything in a single array. Look, my friend, this is not possible. Why? Because we are having an element of integer data type, we are having an element of character data type, and at the same time, we are having an element of bool data type also. This is not possible. The very first requirement for an array is that it should have all the elements of a single data type. What is a contiguous memory? We'll be understanding contiguous memory. Oh, sorry, I thought you won't be able to see this false because of my face right over here. I'm sorry, I will keep that in mind. Now I'm having contiguous memory. What contiguous memory is? You can consider it like, let me tell you in simpler words first. In your memory, in your memory, we make a memory block we make a memory block and we allocate this memory block to an array. Now, let's now understand how we declare an array, the array declaration. I know this is very basic and most of you would be knowing about this, but yet it's my job to cover this. Array declaration in C++ is, let's say you want to make an array of integer data type. Int, first of all, we will define the data type of the array. The second thing is you will name it. You can name it anything. Raju, Mama, anything, whatever name you like, you name it. And let's say a common convention is we name an array as R. Int R, these square brackets. And if we want to provide, initialize it with the value. See, there are two options. There are two options. You can either initialize it with a value. You can either initialize it with value or you cannot. Let me tell you how you are going to do both of these cases. Let's suppose you leave this curly bracket, this square bracket empty. That means you are not telling the size of the array here in this curly bracket, but you will be telling the size right over here. 1, 2, 3. You have declared an array with three elements. That means your this array is of three size. You could definitely have an array that is having just two elements. You can declare an empty array as well. There are all the possible cases. This is how you declare an array. Let's suppose you want to declare an array of some particular size in this square bracket only. I told you now, you can either assign it a value or you cannot. You can leave it empty. Let's say you similar thing, the data type of the array, the name that you want to give it, and I want a five size array, and I will give it my values one, two, three, four, five, or what all values I like. These are the two methods how we do it. Now, once you have learned how to declare it, what's the next thing they're gonna do? I was telling you about the contiguous memory allocation of the array. That means if I am declaring an array of size 3, please focus over here. If I am declaring an array of size 3, then in the memory, I will get a 3 size memory block. We will get to know about the size just in a moment. Just note that if we have declared an array of size 3 in the memory, we will get a memory size, a memory block of 3 size. And how are we going to read these blocks? This is the zeroth block. This is the first block. And this is the second block. In general terms, how do we read it? We read it like this is the first block, this is the second block, this is the third block. But here in programming, we read it like this is the zeroth block, this is the first block, this is the second block, which is called zero based indexing. Now, since we know that this is 0, 1, and 2, three size memory block is allocated in the memory to this particular array. All these blocks will be adjacent to each other. Adjacent to each other, I would like to rephrase it like adjacent to the previous block. Let's say 0 is stored at a particular memory address of 1004. It won't be, it's just an example. We will just code it up and verify what I'm saying. Let me just complete what I'm trying to make you understand. And we know that integer takes 4 bytes of memory. So our array that has three elements of integer type will be of what size? 12 bytes. And just now, I said that arrays are contiguous. What does that mean? If the first element or the zeroth indexed element is at address 1004, the very next element will be at the memory address 1004 plus 4. That is 1008. In the similar manner, I know you know basic arithmetic. Please use your brain. If the second element is at a memory address 1008, add 4 and you will get 1012. Now I'm going to tell you a very interesting fact. Whatever array we have, let's suppose, let me declare a new array for you. Int R5. Int is the data type of the array. R is the name. 5 is the size that we're going to allocate to our array. And store 1, 2, 3, 4, and 5. When my R in C++, please listen this very carefully. In C++, my this name R acts as a pointer. Acts as a pointer. What are pointers? Pointers are special type of variables. Pointers are special type of variables that point to the address of a memory block in the memory. I know it can be a bit confusing, but pointers is a whole different concept than arrays. But remember that the name of the array is a pointer in itself. I'll be making a separate video about pointers, and we will be covering everything about in and out about the pointers. For now, just have a leap of faith in me and believe me what I'm saying. That in C++, this name of the array is a pointer. So, according to the definition, a pointer points to the memory address of any element. So we have five elements over here, isn't it? We do have five elements now. We have five elements over here. The zeroth indexed element, the first indexed element, the second indexed element, the third, and the fourth. Then if there are five elements in the array, and the name array in itself is a pointer, and a pointer points to the memory address of an element. So to which element is it pointing to? It always points to the element zeroth indexed. This arrow always points to this element. Believe me. And just now we will code it up and see if whatever I'm saying is right or not. This is our VS Code. This is our code editor. Let's just initialize hashtag include IO stream using namespace std int main return 0. Our boilerplate is ready. What I said, we will initialize an array int r5. Nothing different, absolutely same. 1, comma 2, comma 3, comma 4, comma 5. Please see out app. And I will run this again, run the code. And see, you got something 0x61FEFC. Don't get overwhelmed by looking at this. We'll break this for you. What did we get? What did we get? We got something like 0x6E, FC, FE, anything, something like that. Let's just check again. 61 FEFC, 61 FEFC. All right. 61 FEFC. 0x is nothing, but it tells us that it's a hexadecimal notation. We know that there are majorly three types of notation, three or four, I don't know. Binary, decimal, hexadecimal, octal, four. All right. So this is the hexadecimal notation where we write in the form of 0, 1, 2 till 9, then A, B, C, D, E, because they're 15, not as they are. A, B, C, D, E. So this is not what we are studying about. It's just the hexadecimal notation, and it prints us and it gives us the address of the zeroth index. All right. That means what I'm trying to say is that this is the address. This is the address. This is the address of this element. Yes, exactly. I'm trying to say that. My array name. See here we have the array name only. What is ARR? ARR is the name of the array. This array, when I'm printing this array, then this array holds the address of this very first element. All right. Now, what if we want to, I want to know about the address of this second element, or I want the address of this, what is this fourth element, or the third indexed element. What if I want to know about them? Then in that case, what you're going to do, my friend, is very basic mathematics. Once we know two or three things. First, what is the data type of the array? What is the data type of the array? Second, what is the address of my zeroth index? These are the two things that we need to know. And third, which index address I want to know. Let's suppose we will assume again. It's just assumption and logic. Let's say this is having the address 1004. What is the size? It's plus 4. And what would be the address 1008? In the similar manner, we'll be doing it in the code also. For this, we can derive a general formula also, though no one is going to ask you, not even the interviewer, nowhere it is going to ask you. It might get in the MCQ questions or somewhere in like small companies, though it is not a very easy topic. The interview is not going to ask you this. If an interview is asking you this, then I'm not a very big fan of that interview. Let's say we were deriving a general formula. So you just have the address of the very first element that you will have. Um, all right, let me do it like if I want to get the address of any ith element where I is the index. I hope you know this. And the formula would be nothing but the base address. Base address is the address of the ARR plus I into size of element. This could be a general formula. Next thing, now we have covered the basics, almost all the basics. Now I'll be telling you why this array is useful. See, coding is coding afterwards. It's first logic and imagination. So let's just imagine a block having four parts. Right? Every part is having its index. There are four parts. Imagine the first part is 0, 1, 2, 3. If I want to access the second part, can I do it? Can I do it? Yes, you can do it very easily. What is the big issue? You are having something like this. It is having four parts. I want to access its this part. I can go and access this. Getting it? So this accessibility, that is every block has its index and we can access them easily. And how easily? In just a single go. In just a single go. So what is the time complexity for this? It's just big O of n. Time complexity and space complexity is a very important part of data structures and algorithm. Interviewer is going to ask you about this. You need to have a hold on the time complexity and space complexity of each and every algorithm, each and every data structure, each and every operation, or each and every solution that you are going to perform. So why big O of one? Let's suppose this is the array one, two, three, four, 0, 1, 2, 3. I want to access the second index element. Go to the second index. What's a big deal? You have the element. That is why I'm saying it's a single go process. That is why the time complexity is also one. Now, if the accessing if the accessing of the element is so easy, that means this data structure is really very good. No, it is not. Let's understand what is the drawback. The drawback for this data structure is that it is having a fixed memory size. That means once I have created an array of size 4 in C++ or Java, there is no power in the world who can change the memory size of this array unless and until you create another array of the greater size. It's like you create an array of R5 and then store all its value in this 5 and then have an extra free space. Unless and until you are going to do that, you can't get an extra space. And that too also is not an extra space. That means that's not an extra space you are getting in this initial array also only. You are creating a different array and then increasing its size. That's not fair. Fair, it's like that's not a proper use case. If you want to increase the size of the array or you want a dynamic array, then we have vectors for that. We'll be learning about them in the STL. That's standard template library. Every language has their. I guess C++ is having its STL. In Java, it's called something else. So you were discussing the drawback. Yes. All right. Let's say I'm having my one over here, two over here, three over here, and four over here. If I want to insert an element at the second position, 0, 1, 2, 3. By second position, I mean at the index number 1. At index 1, if I want to insert something, then first of all, the array is already full. We cannot. If we try to do it, then we will get a new element over here, but we will miss some of our elements. That's a different part. We will be discussing about that when we are doing the rotation of the arrays. The rotation, or I could say left shifting or right shifting, that ultimately leads to rotation of the array. That's also a specific niche of questions that we have in this topic array. Let's say my array is not completely empty. That means completely full. That means my third index is empty. My third index is empty. And what I want to do, I want to store, I want to store four number at index one. At index one, store four for me. So the code part of that is a different question or different neat question. That's left shifting or right shifting, left or right shifting. We'll be doing that differently in separate videos. In the upcoming video, this is the very first video on the channel. Um, but to get tell you the a basic overview, what we will do. All right. So we have the problem that at the first index, I need to store the value for. All right. Then I will start traversing it from the back. And you will get these intuitions once you keep on practicing. And we will be practicing. I'll be uploading the videos. You go through the videos and solve those codes once, and you'll be good to go. If I have my 3, which is at the second index, stored in my third index. And similarly, that means when I was at the third index, I want the value of my second index to be stored in my third index. Now I move. Now I went to second index. I'm traversing from the back now. So I was at 3. Now I'm at 2. So now I will traverse. So now I will store the value of my first index in my second index. All right. So store the value. So have 2 over here. Have 2 over here. Now I will move forward again. Now I will be at first index. And I will check if I am at the index at which I have to perform the operation. Yes, I am. If I am, when you are at the index, please add it now. Please add the value that you want to add. And see, you have 1, 4, 2, and 3. So the drawback here is, so the drawback here is, if you want to um, insert an element in the middle, or you want to delete in middle, or let's say you want to find an element or search for an element in unordered format. That means your array is not unordered. Um, unordered means, yeah, it's like very basic. Unordered is like elements are like 4, 5, 7, and then 6. Ordered is what? 1, 2, 3, 4. It could be 4, 3, 2, 1. There are these two scenarios. Na? In these two cases only you could say that the array is ordered. This is unordered. So when you have to find an element or search for an element in the unordered format, so array is not like a very good option. We have better alternatives for that. So like this was it for the video. And in the very next video, I'll tell you what we'll be doing in the very next video. We'll be discussing some very beautiful patterns about arrays, not about arrays, about the problems that we solve in arrays. There are some very fundamental not fundamental patterns, some very common patterns or the very common interview patterns that you will find in arrays. And we'll be discussing about all those patterns in the very next video. If you want, I could tell you the names. We'll be doing two pointers. It's a very important pattern. We'll be doing sliding windows, and we will be solving some problems also from the next video. Um, what else? A prefix sum pattern. I've just noted down the snippets that I want to teach right here in the page. That's why I'm looking there. So that's it for the video. I hope you liked my video, and I'll try to be more descriptive, and I hope you enjoy my content. Thank you.